So this is called substitution with two terms and coefficients. That's the creeper thing that touches things. And so let's show you what I'm talking about here. So again, you're going to look at this equation and you're going to want to do substitution. And you're like, okay, well, which of these two equations has the variable alone? And I look and I see the bottom one, I have y equals all of this. So I can use that equation to substitute. So I want to substitute this y into the equation above, and I want to substitute for this y, so I'm going to replace that with parentheses. Now the problem with this though is when I go to substitute this 4x plus, I have a 6 on the outside of these parentheses. This is where Mr. Nelson's parentheses and Ms. Garcia's parentheses first kind of helps us keep track of things. I put the parentheses first so I know that that 6 is still there, and now I have this, and I said, what does y equal? Well, y equals x plus 2. And this is where kids really struggle because they forget that now that I have this coefficient that I had on the outside, in order to get rid of these parentheses, I first have to distribute. So I have to take that 6 and go 6 times x is 6x, and 6 times 2 is 12. And now those parentheses are gone. I'm going to bring down the terms from above. And so now I have this equation. Now this is a multi-step equation. It's multi-step because I have to do some simplifying first. And I have a 4x and a 6x. What's 4x plus 6x? Well, that is 10x plus 12 equals 2. And now that I'm down here, I can now solve this equation. I'm going to circle the equal sign, circle the variable, underline the coefficient, and double underline the constant. 2, 1, 0 solves an equation, so the 2 is the constant. I'm going to subtract 12. I do it to one side, I got to do it to the other. 12 minus 12 is 0. 2 minus 12 is negative 10. And then I bring down the 10x. And then how do I get rid of the coefficient? I'm going to divide by 10. I do it to one side, I do it to the other side. And 10 divided by 10 is 1, but I don't need it because I have an x. And negative 10 divided by 10 is negative 1. Again, that's x, but am I done? No, because a solution to a system is the ordered pair that makes it true. So I know what x is, and I can't substitute into the same problem I just solved. I have to go to the other problem, and that was this problem. And I now know what x is, so I can go and I'm going to substitute the value of x. That means I'm going to rewrite the equation, and where x was, I'll put a parenthesis. And the parenthesis, inside those parentheses, I know x equals negative 1, so I'll put that in there. And this is a quick simplification. Negative 1 plus 2 is 1, and so y equals 1. And the question is, am I done? And the answer is no, because again, this is a lot of beautiful work. But the solution to a system of equation is the point where the two lines cross. And so the x for this is negative 1, and the y is 1. So the solution to this system of equation is negative 1, comma 1. All right, you try it. Did you try it? Did you try it? You better pause and try it again. Don't play it. Okay, so here we go. I look again at this and I say, I need to substitute a value in. And I look and I say, well, the top one I have x alone. On the bottom one, I don't have a variable alone because there's a coefficient in front of this y. So I'm going to use x, and I'm going to substitute what x equals. And that means I have to go to this equation down here. And be careful, when we're doing parentheses, I'm going to be substituting into the x. That negative sign is not the x. It's outside of the x. So whatever x is going to go in here, and that negative stays on the outside like a coefficient. If it helps you, you can put a negative 1 there, and that kind of lets you keep track of that 1. And so now I'm going to rewrite this equation. I have 2y equals negative parentheses plus 5. And what does the x equal? We said it equals y plus 3. And again, some people get kind of confused in this. They just want to drop the parentheses. But remember, if you put a 1 out front, like we did above, you know that we have to distribute that negative 1 through the entire through both terms. So negative 1 times y is negative 1y, or just negative y. And negative 1 times 3 is negative 3. Now I can drop the signs. I get 2y equals negative y minus 3 plus 5. And now this is sort of a nightmare of a problem because you got variables on both sides and I still have stuff I need to simplify. So let me start off by simplifying. Negative 3 plus 5 is 2, so that gives me negative y plus 2 because I added these two terms together, equals 2y. Now the next step I have to do is try to get the coefficient to one side. It's not the coefficient, excuse me, the variable to one side. And so that's when we decide, well, which variable do you want to move? Do I want to move the 2y or the negative y? I think I'm going to move the negative y because I like to keep things positive and upbeat. So how do I get rid of minus y? By adding y, and if I do it to one side, I have to do it to the other. Y, negative y plus y is 0, that leaves me 2. And 2y plus a y, that's really a 1, gives me 3 y's. And then finally, I got a one-step equation. So I'm going to circle my equal sign, circle my variable, underline my coefficient. To get rid of my coefficient, I'm going to divide by 3. And people say, oh, this can't be right because it's not a whole number. And the reality is, 99% of the time, in reality, when you do a systems of equations, the answers are ugly, disgusting, 2.987, it's negative 27.3. It's usually never. In fact, if you go to the grocery store and you go to checkout and they say, that'll be exactly $10, you'd be like, whoa, that's weird. Because the reality is math is ugly. And so if you did your work right, then you know you should be okay. So I know what y is, but I'm not done yet because I still need to find x. And again, you cannot substitute your value back into the equation you just worked on. So I'll go to the other equation, and I want to substitute for the y. So I'm going to replace the y with parentheses, and then in the next problem, when I rewrite it, I'm going to substitute what that value is. It's 2/3. And now it's a simple addition problem where I'm going to go x equals 2/3 plus 3 is 3 and 2/3. Am I done? And the answer is, I hope you said a resounding no, Mr. Craig. I have to put this as an ordered pair, which is x and y. And so I go, okay, x is 3 and 2/3. And y is 2/3. So this is what Mr. Nelson was talking about at the beginning of this whole unit, which is sometimes when you graph, the intercepts are not perfect. Meaning it's not like a whole number and a whole number. This is still where those two lines intersect. They just intersect at an ugly point. Now, if you're ever scared and you don't know that you got this right, what you can do is take your values and go ahead and substitute them back into the original problems and see if they equal each other. If I substitute this back in here, will 3 and 2/3 equal 3 and 2/3? Yes. If I plug this or substitute back into this equation and put a 3 and 2/3 in here for x and a 2/3 in here for y and simplify, will they equal each other? If they do, then my answer is correct. All right. Go ahead and try this one. You didn't try it. I'm talking to you. You didn't try it. Try it now. Okay, hopefully you did it and you got this. You just want me to check it, so I'm going to go pretty fast here. I'm looking at the bottom variable because that's where y is alone. I'm going to be substituting that value into the y above, so I'm going to drag this down here and say I'm going to substitute this y. So I'm going to go 2x plus 3 parentheses. There's no rule, there's no rule that says your parentheses have to be small. You can make them as big as you need them. And then I'm going to substitute the value in. The value of y that I'm using is x plus 2. And I have a coefficient there, so I need to distribute. 3 times x is 3x. And 3 times 2 is 6. Bring down the 2x from the equation above. Now I'm ready to do some simplifying. 2x plus 3x is 5x's plus 6 equals 1, right? Now I got to circle the equal sign, circle the variable, underline the coefficient, double underline the constant. 2, 1, 0 is how you solve an equation. To do that, I'm going to go minus 6. Minus 6, I get 5x equals negative 5. And now I got to get x alone, so I divide by 5. Divide by 5, get rid of the coefficient. 5 divided by 5 is 1. And x equals negative 1. And am I done? No. That's right, I'm not done because I got to go find out what y is. Again, I can't go back to the equation I was just working on. I have to go to the other equation. And I'm going to substitute x into that equation. So I'll go y equals substitute x plus 2. And my x was negative 1. Negative 1 plus 2 is 1. So y equals 1. Am I done? No, Mr. Craig. Why? Because the solution to a system of equations is the point where they intersect. And why do they intersect? At negative 1, comma 1. Well, thank you, Mr. Craig. Oh, you're welcome. And if you're not sure if your answer is correct, you can go back in and substitute into each one of the equations and see if it works. All right, hope that was helpful. Go ahead and try the activity on your own.